A baseball is thrown from 9.5 meters above ground, so we're not starting on the ground, reaches a maximum height of 11.5 meters at 4.25 seconds. So I'm just gonna give a little sketch here where this is my time and this is the height. Sometimes this is distance and height, so you gotta watch out. So we're not starting on the ground, we're starting off the ground. And unless otherwise indicated, we're first gonna go up and then down. Oh, I should be careful with this one. My bad, my bad. Unless it tells us otherwise, we're assuming that the ball will land at some point, okay? So this is the important one, right? At time 0, we are at point almost a meter off the ground. We reach the max. It tells us that we're gonna end up higher, so obviously this is what's happening, right? We're going up before we go down. So this is 4.25, 11.5. And please resist the temptation to come up with this point. You don't know that one because you have nothing across, right? So you want to travel immediately across your starting point. So that's where you're going to end up later on, okay? So, so this is where I'm going to maybe show that you can use the axis of symmetry formula, but in this case, we would just double this. We're doubling this because we don't know what the, and we end up with the same initial height again, okay? So that's something to watch out for there. This is 850, so it's times 2, right, to get this. This is the most important piece right now. That will be worth a mark, a full mark to come up with this, okay? Now that I have them, I'm going to write them down. 0, 0.95, okay? After 4.25 seconds, I am at 11.5, and after 8.5, I'm back to where I started. Unless I give you 3 points explicitly, like I just give you the points, you should see that the initial height comes back. Right? You should see that these are matching. So if you had started on the ground at a height of 0, you should come back to 0 if you're going to use symmetry, okay? So you kind of are forming your own mini parabola that you're considering just right there in this case. So please don't fall for this being the point that you're trying to find, okay? It's this one. If you do the, I'm going to type this in just to show you how to do it. I already did type this in earlier. So stat, calc, quadratic regression, second 1, comma, second 2, comma, alpha trace, paste it into Y1, you hit enter, you write down the equation to 2 decimals, but we're going to use all decimals when we're working with it. Okay, so this is what you need to write down. Write down stat, calc, quadratic regression. Next year, next year the quad reg part is not always going to be quad reg. Next year, there's going to be 3, 4, 5, 6 different ones that we're going to use next year. But this year, it's always quadratic regression. Remember, I designed this course to get you ready for grade 12, so I'm kind of very much in line. So next year, this will not be a surprise to you. You'll be like, yeah, I've seen this before. Right? The progression of buttons that I press is about the same. So usually, you get 1 mark for the points, and you get 1 mark for the equation. So if you have to do that all in one shot, which today's AC is going to make you do both of these at the same time, come up with the points first, whether you want to do a sketch or you want to, if I give you a table, I need you to fill that in. Even if the province gives you a table, you need to fill it in, okay? But you may do this on the side to help you out before you introduce them. Now it says how long is the ball airborne? How long does it remain airborne? It's airborne for the entire flight until it hits the ground. So now we're interested in the x-intercept. So it's supposed to be 8.69. Let's go ahead and find it. So please graph it as well. So I'm going to graph this. doing a pretty good job as is for me. Remember, if you turn on plot 1, only turn it on when you're using L1 and L2. Only at that point. If you're entering this equation manually, because I gave it to you, turn this off. Because there will be instances where you try to graph and it's just not going to do it. So that is the first thing I want you to check. I'm going to do zoom stat. Okay? And it actually zooms into those points. And more importantly, guys, this is going to be very important later on. I do see a little bit to the left of the y-axis, and I do see a little bit below the x-axis. That is important. How do you ensure that happens? You press window. You want x-min to be something negative, and you want y-min to be negative as well. So that's something that I always check for. And then I change my x max and y max if necessary. Okay, so I hit graph again. I have those 3 points. Now I'm interested in the x-intercept right there. So I'm going to go, what do I do for x-intercept? I let y2 equal to 0. I hit graph. I'm not interested in this one because it's negative time. I'm only interested in this one, second trace intersect. I'm going to travel a little bit closer to that one. That's good enough. Enter, enter, enter. And there it is. It's hard to see, but it's 8.69. So I will just go y2 is equal to 0. This is your work. This is the alternative of having to do a whole bunch of algebra. In pre-cal 11, you do the exact same thing. You do parabolas, quadratics, but you do it algebraically for the most part. So this is 8.69 seconds. Whether you want to state this at some point like this, I like that you keep on thinking, okay, x-intercept, that's what I'm finding, but it's 8.69 that is answering the question here. So if you want to make absolutely sure, you circle that. That's my final answer. Here are more questions. What is the height of the ball after 7.75 seconds of throwing the ball? So basically what this is saying is, if x is 7.75, what is y? What is the height? And when you have the x value, you want to use second trace value, and you want to let x be 7.75. Okay? 74. All right, so we do that. Second trace 1, 7.75, and you find out that it's here. You want it to blink where it's supposed to be. So our height there is 4.34. Okay, y is 4.34, and we are in meters. Just add a unit to it, and you get full marks there. Are we good so far? Clear? Clear? Yeah. And now, I feel like sometimes I add too many layers to the question. Maybe what I should have just said is, hey, what's the domain and range in this situation, just given the problem itself. Okay? Some of you did the homework and you have an answer here. Okay? I'm adding a curveball, pardon the pun. If the ball is caught 0.5 meters above ground. Okay? So how about we break this down into two scenarios? I will cut this in half here. You know what I will do? I'll do that. I'll use the side here for domain and range without being caught. Okay? Domain and range, just add that here. If not caught, basically hits the ground. Let's do that one first. That's the one I would like you to know how to do. What would be the domain and range if you don't catch this ball. It hits the ground. In other words, let's do this real quick here again. We know this is 8.69, and this would be 0, right? So our domain in this case is from time 0 till when it hits the ground. Okay? That means my domain. My range, since it hits the ground, right? The lowest is 0. The highest is given to me by the vertex. And what's the highest that I ever get to here? 11.5 meters, right? That's the highest point. This is my range. That's my range. And remember, always smallest number first, highest second. So I like this to be the background of what we're doing here. This would be the basic domain and range if it hits the ground. And now I'm adding the layer to it. What if the ball is caught half a meter above ground? Meaning, pay attention to this part, right? You're going to start here, it's going to go up, and it doesn't hit the ground, it stops somewhere here. Okay, it's somewhere above the ground. So let's sketch that scenario. It's so tight there. I really apologize for that. But let's try to make this work. We start at a height of 0.95. This is 0.95. We go reach the max, and then we are stopping here, right? And we know that that height is 0.5, but we don't know the x value. Like, we don't know when, what time does that happen, okay? So we need to find this point. We need to find the x value at that point. So I'll let y2, since I know the y value, I'm going to let y2 be 0.5, and then I'm going to find the intersection. Note to myself, give more space here, right? So let's do that. Instead of hitting the ground, we're now off the ground. It's being caught there somewhere. So let's go and investigate. Second trace intersect. I'm going to go a little bit closer to that side. Enter, enter, enter. And there it is. It's 8.59. X is 8.59 seconds. So how does this change my domain? I go from time 0 until it is caught, which happens at 8.59 seconds. The range, what is the lowest height in this whole story here? It's 0.5, right? That's the lowest I ever get to. I don't hit the ground, so 0.5. And the highest is given by the vertex. Okay? So that's how this would change. So if it doesn't hit the ground, sorry, if it hits the ground, it's here. If it's caught, it changes things. Okay? Changes things. Let's do the graph real quick. Might as well. This is time in seconds. This is height in meters. I need to go all the way out to, well, this is being caught, so I'm going to go with the 8.59. So I'm going to go 2, 4, 6, 8, 10. That works perfect. That makes sure I go up consistently by 2s. And then here I'm going to go up to, I need to make sure that, oh, you got to be careful here. I need to make sure I accommodate 11.5. That's the highest, right? The highest here. So 2, 4, 6, 8, 10. That's not going to cut it. So I'm going to go 3, 6, 9, 12. This would be 15. And so 0, 0.95, so this would be 1.5. So technically, 0.75, 1. Everything is 0.75. So this would be 1.5. So this is where I start. Somewhere there. The highest is at 4.25. This is 5. 4.5, 4.25 is right here. 11.5 would be right here. And I can go by the 8.59. This is 9, 8.5. This is just over 8.5 at a height of 0.5 right there. Doesn't hit the ground. So I go from there to this point, from there to this point. And I'll label my graph as well.